Hello everybody. In the first part of this lesson, we solved and graphed one-step inequalities, and we only encountered with addition and subtraction. But here now, what we are doing now, this is the first part we've done. And now we are going to solve also one-step inequalities, but this time we'll find ourselves against multiplication and division. But the idea is pretty much the same, except for the fact that here we have one trick appeared. So anyway, not in the first one. 4 is greater than y over 3. We have to understand what our y is, and to do that we have to isolate y. So we have to remove this 3 down here in the denominator. How do we do that? By multiplying both sides of our inequality with the same quantity. By the same quantity multiplied by 3. This is our solution. So 4 multiplied by 3 is greater than y over 3 multiplied by 3. And this 3 is cancelling here, of course. That's my answer. 12 is greater than y. The only thing I want to rewrite it so that to get immediately set builder notation. Y is less than 12. That's already set builder notation. Again, we are writing in 3 possible forms and in 3 forms which we have to know. Now we have to graph it. So y, it's less than 12, so it will be to the left from 12, and I draw a circle around 12, and then that thing goes to infinity. And the last thing I have to do is to write an interval for that, interval notation for our solution. It's from negative infinity to 12, open interval. That side with infinity is always open, as we know and as we stressed many times. But this one, the side with 12, this is, it can be open, it can be closed. In this case it's open because we don't have equality sign here. Here, if we did, it would have been closed. Pretty easy. Here in number 2, pretty much the same problem. R over 2. All we have to do is isolate r, remove that 2 in the denominator, and we do that by multiplication. Wow! 2 by 2, it's 9 by 2. 9 multiplied by 2 is greater than r over 2 multiplied by 2. And this 2 again cancels here, and we have 18 is greater than r. Again, I rewrite it to get a set builder notation answer. R is less than 18. Then, for a change, I'll write first the interval notation. Again, it's to the left from 18 to negative infinity. So a set builder notation gives me and 18, and it's open. All right. I wanted to go further, but actually I have to graph it. So I don't include 18, it's open, so that's why I write draw a circle around 18, and well, I put it in the opposite direction. Okay, let me draw it properly to negative infinity. All right. This one is pretty much the same. we have to isolate this x. Again, we're doing that by multiplying by 6 both sides of the equality. Negative 10 multiplied by 6. Here 6 cancels, which gives me x is greater than or equal to, and negative 10 multiplied by 6 gives me negative 60. So it will be to the right from this number, and to write interval notation, I get this. It's negative 60 closed and stretching right to positive infinity. Here I have to graph it finally, as my point is included. In other words, my interval is closed from this end. This end is closed. I draw a solid circle and go to positive infinity. Here we have our first tricky thing, namely this negative sign. When the quotient next to our variable is negative, like in this case, negative 3 is multiplied by b, I have to isolate b by dividing by a negative quantity, in this case, namely it's negative 3. When I do this, I change the inequality sign. By changing, I mean that I change like this. The direction of my inequality sign changes like this. So let me, in this case, to be absolutely exact, and I'll rewrite the original to show you that when I divide by negative 3, I change the direction of my inequality sign. Here negative 3 cancels, but the trickiest part, of course, is this flip of the sign, change of the sign. We shouldn't forget that. We mustn't forget that. So this is when we multiply or divide by a negative, we have to flip the sign of our inequality. This is the only trick. But it's pretty. It takes some concentration not to forget about this. And now we have isolated b. The sign has changed, and negative 15 divided by negative 3 gives me positive 5. Positive 5. That's the final solution, which is already in set builder notation form. To write an interval, I understand that it stretches from negative infinity to 5 open. To graph it, I draw a circle around 5 and then go to right to negative infinity. In number 5, that's it. Everything is fine. We're good to go to the next one. In number 5, we have the same problem. We have a negative quotient in front of n, negative coefficient quotient, like in IQ tests. So we have to change, dividing by, after division by negative 6, we have to change the inequality sign. I won't rewrite the original inequality in this case, just divide immediately. And here I change 60 over negative 6. Negative 6 cancels. What I have here is n is greater or lower than, less than, and took everything. N is less than or equal to the right side, which is 60 divided by negative 6 gives me negative sign, and it is 10, negative 10. This is my set builder notation answer. Again, it stretches up to negative infinity. So this is interval notation, which I'm writing here, negative 10, and it is closed. This end is closed. And now I have to graph it, and here is negative 10, and this is it. So the only thing you have to watch out for, and this is this negative division or multiplication by a negative quantity. Here we don't have anything negative, so this one is not to get used to always flipping the inequality. For a change, we just multiply by 6. 9 multiplied by 6 is less than d over 6 multiplied by 6. This cancels, which gives me 54 is less than d, which finally gives me d is greater than 54. That's it, my set builder notation. Now I have to write an interval notation. This interval stretches from 54 open to positive infinity. And as a final step, I have to graph it, which gives me a pleasure to draw a circle around 54 and then to positive infinity. And then to go right to positive infinity. Of course, I can't go directly to positive infinity because it's too far. It would be to go too far. Here, this negative sign shouldn't concern us at all. Only this negative sign matters, and this one we don't have any negative signs. So we just multiply by 5 again. It's all right. V over 5 multiplied by 5 is less than negative 8 multiplied by 5. And this 5 cancels, which gives me V is less than 8 by 5 is 40, it's negative 40. That's my set builder notation. Interval notation gives me from negative infinity to negative 40 open. And the last thing to do is to graph it. As this end is open, I draw a circle. And then. We are nearly at the end. Here we have both negative signs, but again, only this one concerns us because it stands next to g, which I have to isolate, and that's the only concern of mine. So, negative 42 I divide by negative 7, and I flip the sign of the inequality because I have divided by a negative quantity. So negative 7 multiplied by g and divided by negative 7, which gives me negative 7 cancelled. Here gives me positive 6. 6 is greater than g, or again, to be more comfortable, I rewrite it as g is less than 6. This is my set builder notation. And to write the interval notation, I have to go from infinity is too slim. The sign of infinity was too slim in my performance. So up to 6, and this is a closed end. This is it, and graphing it, I'll just have to draw a circle around, no, not a circle, so that this one goes right to the negative infinity. Well, 2 to go. Here again we have a negative sign, but it doesn't concern us at all because here we have a positive sign. So we're going to multiply by 2, by positive 2, and it's fine with us. I mean, we don't have to flip the sign. S over 2 multiplied by 2 is less than or equal to negative 13 multiplied by 2. This one cancels, and this gives me already set builder notation negative 26. Here we go. Again, interval notation, negative infinity up to negative 26, and this is closed because of this sign, which includes equality, equal sign. And the last thing to do is to graph it. Here we go. I include this point, close this interval, and go like that. Here is the last one. The last one again reminds us of the necessity to flip the sign of our inequality in case we divide or multiply by a negative quantity. So in this case we have to divide, of course, to isolate f, and we get 28 divided by negative 7 is less than negative 7f divided by negative 7. Negative 7 cancels, which gives me negative 4 is less than f, but it means, I rewrite it again, f is greater than negative 4. This is my set builder notation. Our interval notation starts with negative 4 and stretches right to positive infinity. And as there is no equality sign, then it's open interval, so I don't include this point. And finally, I draw a line along my number line, and it looks like that. I have to find negative 4, find and draw a circle to indicate that I don't include this point, that my interval is open at this end, and draw it up to the end of my number line actually, but of course I suppose that it's going right to positive infinity, which is a nice idea of, like universe, like Einstein used to say, that universe is infinite. So that is it. Again, summarizing what we did, we solved and graphed the inequalities, one-step inequalities, which included multiplication and division. And here we encountered a difficulty, which actually it's the only difficulty and the only difference between solving equations and inequalities. In equations, equality sign, it's always symmetrical. A is equal to B means immediately that B is equal to A. But here we have to watch out about situations in which we divide or multiply by a negative quantity, and in this case we flip the inequality. How many times have we flipped? In number 4, this was the first time where we flipped the sign of inequality. Then in number 5, it's 2 out of 10. Here no, here no. Here in number 8 we flipped, and in number 10. In 40% of our inequalities we have to change the sign due to multiplication or division by a negative number. Remember that and you'll be fine. I hope to see you soon. Have a nice time.